welcome back to my channel. So in my video today I am going to focus on differential calculus, and I'm going to look at exponential functions and their derivatives. So hope everyone knows that the derivative of the basic exponential function e to the power x, so the d by dx of e to the power x is e to the power x itself. So in my video today, I'm going to look at different variations of this question. So first example, e to the power 5 of x. So as you can see here, the coefficient of x is 5, it's not 1, which means we have to apply the chain rule. So we are going to find the derivative of the outermost function, which is e to the power 5x, and then find the derivative of the innermost function. That's a chain rule. So if you do that, you get something like this, because the derivative of 5x is 5, and then you can simplify and rewrite it as 5 times e to the power 5x. So this is the derivative of e to the power 5x. Very easy example. Moving on, we've got something slightly complex, but not too bad. So we've got e to the power of that quadratic function. So in this question, we are going to use the chain rule once again. So let's assume the power there is equal to some letter u. And then we are going to now derive the u with respect to x. So when I derive that, that's going to give me 2x take 4. Now what happens to my original function y? That becomes e to the power u. If I derive y with respect to u, I get e to the power u. So this now, the chain rule, dy over dx equals dy over du times du over dx. So dy over du was e to the power u times du over dx was 2x take 4. So I'm going to write it as 2x take 4 times e to the power u. Now I can do lots of things to this question. I can see that the 2 is common out there, so I'm going to take it outside the bracket. That leaves me with x minus 2 in the bracket, and then the u is not u at all. We're going to bring back the original function, so that's x squared take 4x plus 8, and that should be our final answer. Moving on to our next example, well, the power now is a cubic function. So just like our previous example, let me assume that the power is some letter u. So now I am going to differentiate u with respect to x. So that will give me 3x squared minus 4x plus 9, and negative 10 is a constant. So y, which is our original function, becomes e to the power u, and once again dy by du is e to the power u. Apply the chain rule once again, would give you dy over du, which is e to the power u, times du over dx, which is 3x squared take 4x plus 9. And the last step would be, we can't factorize anything, there's nothing common there, so I am going to bring back the original x cubed take 2x squared plus 9x take 10. And that's our final answer. Right, shall we move on to our final example? This time we've got a logarithmic function there. So we've got ln x times e to the power 3. So because this is a product of two different functions, we are going to make use of the product rule. Now there are different versions of this in your methods formula sheet. You could use the uv or f of x, g of x. I personally prefer the uv, so I'm going to make use of the uv formula. So u times p dash, so first function times the derivative of the second, plus the second function times the derivative of the first. Now I'm going to assume that u is our first function, which is ln of x. And therefore, u dash is 1 over x, because the derivative of logarithmic function is 1 over x. And I am also going to assume that the second function is some other letter b, so b dash is e to the power 3x times 3. Remember our first example? Using the chain rule. So in an exam, it is important to show that step there. It's important because they carry marks. You must state and define the first and the second function. Now I'm going to apply the product rule to differentiate. So dy over dx with the application of the product rule is the first function. So ln of x times phi dash, which is 3 e to the power 3x, plus the second function e to the power 3x times the derivative of the first function. So now I can see there is the e to the power 3x that's appearing, so it can be factorized. So e to the power 3x outside the bracket, and what's left inside is 3 ln x plus 1 over x. Now you're most welcome to leave the answer in this form because this is correct. Some people might want to take the LCM as x. So that would leave us with e to the power 3x and 3x ln of x plus 1 all over x. And that would be our final solution. Thank you very much, everyone. I hope you understood how to find the derivative of exponential functions. And I hope you like this video. Please subscribe to my channel. Thank you so much for your support. Thank you. Ta-da.